guys, Logic here from OpenWire Security, just giving you a quick video to show you our PHP framework. We've worked really hard on this. This is one of 3 frameworks we've actually developed, the other 2 being Python and Ruby. The idea behind writing 3 frameworks was that a lot of frameworks like Metasploit are geared towards a specific language, and we kind of want to move away from that. We want to give you guys the ability to write whatever language you want to use, and we'll provide it. We're actually working on a Perl version as well. So to get started, you're just gonna open it up, and as you can see here, very simple UI and pretty straightforward. So type help for list commands. So help. So the help command gives you all the list of commands you can execute. Most of them are pretty familiar if you guys are familiar with Metasploit. We're still working on adding tab completion, stuff like that, some features that make Metasploit pretty nice. But let's get started with dropping into a local shell. So just type local, and what it does is drops into a local shell where you can execute commands and see everything. Even allows you to run any programs you install. For instance, let's run nmap, and let's do my local IP, use my system DNS, and then there you go. Shows you the list of your nmap output, all the different ports and the services attached to them. One thing I'm working on right now is actually piping whatever output you have into your framework to use later. So in this case, we could pipe the list of IPs and services behind them to the framework itself, and actually use that for exploit modules. So you can actually execute an exploit depending on the port and service attached to that port. Let's go ahead and exit. Let's bring up the help list again. Alright, so next thing I want to do is just show you the list of libraries we have. So to do that, just type libs. We have 4 types of libraries. Colors is pretty self-explanatory. It adds color to the framework you see here. OS allows you to call functions depending on the type of OS you have. So you could actually call ncat for Linux, and it would drop an ncat shell and kind of have it configured to be able to get callbacks from a Linux operating system. Or you can have netcat if you have like Windows, and instead of like the tacky where it drops bash shell for Linux, you can do tacky command.exe where it drops a command prompt. The text library basically does text encoding and stuff like that. We can do string to hex, string to oct, string to whatever you can dream of. Allows us to capitalize, lowercase, rearrange, replace, all that fun stuff. The webbot class, or library, sorry, is basically holds all of our CURL functions, get, post, some nice threading stuff that we've developed to make exploiting a little bit quicker. Because as many of you know that work with PHP, threading has not come out yet. Coming soon, but still not out yet. So that's pretty much it for the libs. We got another one, core. Core is basically 2 main things. The main core is what holds our banner and the help dialogues and stuff like that. The modules is the meat of our operation. It holds all the listing, loading and exploiting and stuff like that. Holds all those functions and allows us to call this module core library from the framework itself, without having to dynamically load it every time we load something. Alright, next thing we're going to do is we have the list exploits, so let's type that. This is just a list of all the exploits we have. We only got a couple right now. We're still working on porting stuff over. For those of you who've seen the Ruby video, we actually have a lot of exploits. We just need to work on converting them over to PHP. We also have auxiliary modules. Those are like your scanners and stuff like that. A lot of them are pretty quick to make. And if you want, we can actually do video. We'll probably do a video later on showing each one and how it works, and they're actually pretty cool. The admin finder does exactly what it says. Basically goes through a page and searches for admin pages, and if the page returns to be good, basically not a 404 or anything like that, it just says OK and shows a link. Bing search does exactly what it says. Allows you to search Bing. This can be useful if you're doing a pen test for a company and you're doing some Bing dorking. You can actually execute that from in the framework, return some possible vulnerable web apps that your customer might not know about. IP just finds your local and external IP. pscan is just a simple port scanner, and then template, which we'll be looking at in a little bit, is the template I made just to show you how to make a module and all the different types of things that go into making a module. One thing we didn't talk about, I forgot to, was the exploit. The two we have, the SMF 2.0.4 injection actually drops into a local shell. It's very nice. Something that I've been trying to do for a while. Just trying to get a good proof of concept, and that's what I came up with. The Sub-Zero, if anybody follows the news, Hack the Planet actually released a project called Sub-Zero version 2, which allowed you to exploit Cold Fusion version 10 with a password hash, or 9, I believe, with the local file inclusion. We actually added in 6 through 8. Couple of them haven't been released yet. But they all either use LFI or they use like a cookie stealing type method, where it actually dumps the password or the administrator's hash or admin cookie and allows you to log in, and that's only for version 9. Lastly, we have list payload, and we only have one right now. That's actually Pentest Monkey's PHP verse shell. Very nice. If you guys haven't looked at that yet. Works every time. Let's clear that out. Let's type help. So let's go ahead and load a module. So let's load aux. Let's load pscan. Pscan is just a simple port scanner we use. It was more of a proof of concept. It's not going to be in the final product probably, because like I said, we want to use Nmap and other tools like that to be able to pull data in from your local shell and actually use that for exploits. So to see how to actually run this, we just type options. There's a list of options that we need to set. So in this case, we're required to set target. So to do that, we just do set target. Set target. So we have a set. The options is to make sure it's actually set properly. So there you go, it updated. So to run this, we just type exploit. And there we go. There's this list of 4 ports. As you can see, Nmap did a much better job of port scanning. This is just a proof of concept to show you basically how the module structures work. And it was kind of to get us an idea of how we wanted to do the modules. This is the first one we wrote. So that was pretty easy. Let's go ahead and take a look at a module. So here we have the template for making modules. Let's go through some simple stuff. We'll start off with namespace. There's 3 namespaces, aux, exploit, and payload. Depending on what folder or what type of module you write, so let's say you write a scanner, you would put namespace aux and then put it in the aux folder. Pretty simple and straightforward. All of this here is doing, the use framework / framework as framework, is just loads the framework, or loads, just basically loads the framework into, how do I say this? Basically loads your framework into whatever module you have. Class template, all the names, or class names, are unique, and so if you have a module you want to write, all the names have to be unique. We're just extending framework, as we said above. We'll go down here, the name, so in this case is template. This is whatever the name of your template is. Description, so what it does, and then mod name would be how would you call the module itself. And then down here in variables, basically other than target, or if you want you can use target, basically what variables you want to use later on. They're basically, we use them as global variables. It's a lot cleaner, we think, than setting a crap ton of global variables up top. You can just use this, an array, and then you can call from that array at any time you want. So we can go down here. We have check. Check basically allows us to check if a target is vulnerable, if the site's alive or anything like that, prior to actually executing any exploit code or payload code or anything like that. This makes it a lot faster, so you don't have to wait around and like realize it doesn't actually work. This is all going to be coded by the person making the module. We actually don't do any check on our end. It might be something we add later on, but you never know. Exploit. Exploit function, it actually gets called by the framework. So all these other functions don't really need to be public. They can actually be protected, but exploit is what gets called to the framework to actually run. So in this case, it's running this function run, which is down here, which will contain all your exploit code. Post does exactly what it says. It's basically for post exploit, so dropping shells and stuff like that. This also gets called by the framework along with check. So the order of way, or it usually goes, is check, and then exploit, and then after exploit, it checks for post. If there's nothing in post, or we just prints modules not support post exploitation, and then it'll give you an output whether the exploit was successful or unsuccessful. So that's the basic template. Let's go ahead and take a look at pscan really quick to give you an idea of how an actual generated module works. So as you can see here, we had the main pscan simple port scanner, and then the way we called it, which was pscan. We got a variable, which was port range. One thing you noticed that we had a required variable, which was target. If for some reason you have a module that does not require target and you don't want to have anything in there, the simplest way to do that, let's just copy this. The simplest way to do that is to basically add target as your global variable. So target, and then we have it and just set it as required equals false. What this does is it overrides whatever the framework has, which by default is true. It is a required variable, but this overrides the framework and then allows you to set specific targets. This is useful if you have like if you're doing a pen test or anything like that, and you have a specific target you want to use, and you want to set it in the framework, or you have a specific URL you have to use, you can actually specify that in the module itself. So in this case, we'll just go ahead and save that. Let's go back here, clear that out. Load the framework. So let's load aux pscan, and then if we show options, it should say target is not required anymore. This can be really useful, like I said, for different types of modules that you want to use, or if you're doing local scanning where there's no target. Let's go ahead and change that back. You can go scroll down a little further. This module didn't have any checks, so that's not required. Exploit. So as you saw in the template, we used run as to be called by exploit. You can actually specify any function name as long as you change it here. So we had a public function scan, or a private function scan. Like I said, we can use protected or private within here, because within the context of your class, that way you can actually just call that an exploit. Exploit is required to be public, just for future reference. We ran into some issues when we were using it as protected, but you guys don't need to know that. So what this is doing is using scan, and then it's using get host by name, and then it's using whatever target. So the target's set by default by you, right? Because we use set target, and then I use my local IP. The scan, all this is doing is it's just using string position for the port range. It's exploding your port range, and then it does a for each to list each loop or each port, and that's pretty much it. Basically, if it can detect that there is a port using fsocks, of course, it returns true and returns a port and what port that was. For pscan, one of the things they didn't go over is the port range variable. It's not only a port range; it can actually do specific ports. So you could do 80, 443, stuff like that. So if you're doing a specific job, you can set that. But like I said, this is probably not going to be in the final framework, or if it is, it's going to have a lot more functionality. Alright, so that's an auxiliary module. Let's go ahead and load. Let's load an exploit module. Let's load PHP CGI. So this is the PHP CGI. Basically, the PHP info pages, if you have CGI enabled and writable, you can actually exploit them using PHP input. So we just wrote a really quick module that actually exploits that and drops into a shell. So like we said before, we changed the namespace to exploit because it's an exploit. All the same stuff. The class was PHP CGI. We had the name, description, and variables. Page. This is used at the end of the URL. So whatever the location of your PHP.ini is, that's what you would set as your page. And this can be set. It doesn't have to use test.php. You can actually do set page to whatever page, and it'll update this automatically. Alright, so for a check, what we did, we basically checked to see if it was Windows or Linux. To do this, we just used a get call, and then we checked to see if it returned Windows 32, 64, and if it didn't, then we just assumed it was Linux. Alright, so here we have the meat of everything. This is just some echo commands. What this is doing is it's getting contents, and it's checking for the word OpenWire, because basically what I'm doing is I sent a post as echo OpenWire, or you can set this as anything. If it returned true, basically if it showed up on the page when I did the post contents, if it actually shows up on the page and not equal false, it says target is vulnerable, and then it loads the shell. The shell is down here. All this does is uses a pass-through in PHP to execute commands. So we're using readline in this case. One thing that makes life a lot easier is using these markers. So in order, most people, when an exploit like this, they're going to start blocking. They're probably going to block where it says echo OpenWire. One thing you cannot do is we use the string shuffle as kind of like a regex, and it randomizes the string of characters. And what it does is we have it set like in between each side of the pass-through. So this dynamically gets loaded into the framework, and it returns everything in between the two markers. So we had to echo the markers on each side of it, and in between is the command. And this actually works really, really well. It's not the prettiest of shells, but it gets the job done, and I'm actually really proud of it. It took a lot of work. Another one that we wrote was Sub-Zero. This is actually, like I said, from Hack the Planet when they had released version 9 and 10 local file inclusions. We just added a little bit more to it. Let's start off the check. What this does is this returns absolute path if returns a slash. So if you see, let me enter. So in Linux, the way it does an absolute path is / or /opt / whatever. In Windows, it does, right? So what we do is return if the first character returns as a slash, it's automatically Linux. If the second character in the path is a colon, you can assume it's Windows. It's something really simple and kind of like, oh duh, yeah, it makes sense, but it works really well in this context and allows me to execute the Cold Fusion exploits depending on the operating system type. This down here was something that I came up with. So every time you run or you get a new version of Cold Fusion, the one thing that changes every time is the background, because they change it from 9 to 10 or 6 to 9, 7 to 8 to 9 to 10 and all stuff like that. So it has a different MD5 value. So all we're doing is we're pulling the background, checking it against the known MD5 for these three versions, which is this 9 and 10, and then this random one that we are using to make sure to tell you it's not exploitable. But if it returns true in any of those, we can set the version to 9 or 10. Scroll down a little bit. So this is where we actually start running the exploit. What this is doing is basically if the variables for OS and version, so in this case Windows, OS is 10 and version is, or Windows, OS is Windows, version is 10, it runs this array into our little program down here. And the same thing with 9 and stuff like that. We actually added in version 7, as you can see, and 6 is actually down here also. We also have JRun 4 for if you're using on Linux, which is kind of like a free version of Cold Fusion. That's for Linux. Let's see what else. Down here is where we actually retrieve the password hash. So it's using as a get contents, and then it's loading, in this case, the local file inclusion. It's just running these arrays into there. So it does a for each statement to return each single one. Just returns each single one. And if it returns true and you retrieve the password hash, which you can see down here, so it's returning in between RDS password and password. So if it does not equal false, so if it has the word encrypted equals, it goes between RDS password and password and returns the RDS password. And same thing with the admin password. If it's between the password equals and encrypted equals, which is where the admin password hash is when we actually get the contents, then it's actually going to display it out for you. Another thing we added in is a check for version 9. Version 9 was vulnerable to admin cookie stealing in a way. Basically, you could execute this CF, or you could execute a large string, and what it would do is return a set cookie for a CF authorization for CF admin. You could actually execute that cookie, and then it would automatically log you in as an administrator. That's pretty much it as far as modules. If you guys have any questions, feel free to email me, logic@openwiresec.com, or you can email Phaedrus, who is actually the programmer for the Python framework, and his is Phaedrus, Phaedrus, @openwiresec.com. Thanks for watching, guys.